Hi everyone. After today's Zoom class, I decided that I am going to walk you through Assignment 8, Part 2, and scaffold your learning with the answers this week. And there's a couple different reasons for this. One of them is this week is chocked full of a lot of information. And another reason is that we are heading into spring break. And I understand that this is midterm time. There's a lot on everybody's minds. And I don't want this content to get lost. This is really important for you to know this at this time. So what you're going to be able to do today is watch this video, and then it will help you to complete the answers for Assignment 8, Part 2. So let's take a look at the scenario first. It says that a researcher wants to know whether a new soda tax has an impact on buying behavior if people continue to buy soda after the tax. So before the new tax, convenience stores in the city sold an average of 420 sugar-filled beverages per day. So that was sort of the average. That was what was happening. You can call that in the population with a standard deviation of 60. Since we know the population mean and the standard deviation, we can do something called the z-test to figure out if after a tax is levied or assessed, does it change people's buying behavior? So following the implementation of the new tax, data were collected for 9 different days. So that's 9 days is the N. How many days? And the new mean for those 9 days of the number of sodas that were sold was 395. So what we're going to do is we're going to try to figure out if there's a difference between the amount of sodas that were purchased after the tax was enacted compared to before the tax. And so your assignment asks you to do 8 different things, and I'm going to lead you through doing each of these 8 different things. What I'm going to encourage you to do is try to do it on your own first, and then check your answers against the answers that I'm going to provide. Let's get started. The first thing I do whenever I'm doing a problem such as this is I put down all the information that I'm going to need to have, starting with the Z formula for means and the standard error formula. These are the 2 sort of math type of formulas you're going to need. And then I'm going to look at a couple of different things. I have the N of 9, there were 9 days. I have the mean of how many sodas were sold after the tax. I have the population mean of all of the sodas sold before the tax on average per day. And then the standard deviation of 60. I also have alpha 0.05 because that's the level I'm going to test to see if there is a significant difference. So when you're doing a problem like this, I recommend that you do the same thing, that you put everything out on the table, so to speak. Okay, your first question asks to identify the independent variable. So I'm going to call this the IV. So the independent variable, I can just put group, because that is what I'm doing as a researcher. I'm divvying up 2 different groups. I have the population and I have the after tax. So I have pre-tax and post-tax. The other independent variable that you could even just call it tax, because that is the thing that's changing. We didn't have a tax before and now we have a tax. So that is something that has changed. The dependent variable is the thing that's going to vary as a result of being in one of these 2 groups. So what are we looking at that's going to change? It's the number of sodas. So actually I'm going to get rid of this tax here. I'm just going to say that the independent variable is the group that I'm putting you in. Either you're in the full population before tax or you're in the group that's after tax. Population versus sample. And the dependent variable, what's going to vary depending on what group you're in, is the number of sodas. So this is your independent variable and your dependent variable. The next thing you're asked to do is to identify the null and the alternative hypotheses. Now, I'm going to start with the alternative hypothesis first because I think it's easier that way. The alternative hypothesis is H subscript I, or 1, sorry. And I'm going to say that the mean of the post-tax group, that's the group after the tax, is not going to be equal to the mean of the pre-tax group, the population, in other words. What you choose to have for your subscript, as long as it makes sense, that's fine. Now the question is this going to be a one-tailed test or a two-tailed test? Well, we were just interested in a difference. We weren't interested if there were going to be more sodas sold or less sodas sold. We just said we're interested in a difference. And therefore, this is a two-tailed test. Maybe more sodas will be sold after the tax. Maybe less sodas will be sold after the tax. We don't know. We're doing a two-tailed test because the answer could go in either direction. This is the alternative hypothesis, and the null hypothesis is indicated with H subscript 0 for no, nothing, 0. And I'm going to say the mean of the post-tax group, the sample, is equal to the mean of the pre-tax group, the population. As a reminder, we're using mu to indicate population mean. And you might be saying, but wait a minute, this is our sample, the post-tax group, the group that we're pulling after the tax has been enacted. That's a sample, that's true. But we don't write hypotheses about samples. We write them about populations that they come from. So basically, this is saying the mean of all post-tax days are going to be equal to the mean of all pre-tax days. So we make our hypotheses at the level of the population, even though this is actually a sample that we pull. Hope that makes sense. The next thing we need to do is we need to find our critical values, and this is super important. This is going to help you to make your decision. So what I'm going to do is I'm going to draw out where my critical values are going to be based on alpha. So -2, -1, 0, 1, 2. Okay, this is the normal distribution. My alpha is 0.05. That means I'm going to take that 0.05 or 5%, and since it's a two-tailed test, I'm going to divide it by two tails. So what is 5% divided by 2? Well, it's 2.5% in each tail. 2.5% here. And we can make that 0.025 and 0.025. That's how we say 2.5% is the same as 0.025. What we need to do to find our critical value is find the z-score that's associated with 0.025 in the tail. So let's pull up our z-table, our unit normal table. And if we look for 0.025 in the tail, we have it exactly right here. And that equates to a z of 1.96. Now that's more than just 1.96. It's our critical value is going to be equal to plus or minus 1.96. So I'm going to kind of see where this would be on the normal distribution, 1.96. Negative 1.96 would be about here. It's almost at a 2. And then I'll shade in the area that's greater or less than that, actually. And a positive 1.96 would be here. And I'll shade in the area that's more. Now, we think of this distribution as all the possible sample means in a population. And we're going to figure out the z-score for our particular mean and plot it on this potential of all possible means. And we're going to figure out if it's in one of these two extreme areas. If it is, we're going to say there's something going on here that this mean is really different from the population mean. But let's take it one step at a time. What we need to do now is we're going to figure out the z-score for our sample mean. We do that by taking the mean minus the population mean divided by the standard error. And if you remember from last week, standard error is the standard deviation divided by the square root of n. So we can do all of this. Let's start with the standard error first, though. This is taking our standard deviation of 60 and dividing it by the square root of n. So our n is 9, so the square root of 9 is 3. So our standard error is going to be 60 divided by 3, or 20. Okay. Now we have everything we need to plug in our z formula for our mean of 395. Let's take our mean of 395 minus 420 for the numerator. We're going to divide that by our standard error of 20. Okay, so 395 minus 420 is minus 25 divided by 20. So that gives us a z-score of negative 1.25. That's our z-score. That relates to a mean of 395 when you have a population of 420 mean and a standard deviation of 60, standard error of 20. Okay, so now that I have my z-score, I can plot it on the normal distribution to see where this mean would fall with all possible means coming from this population. Negative 1.25 is about here. So the question you need to ask yourself is a z of negative 1.25 in the critical extreme area? And it's not, is it? It doesn't quite make it there yet. So our decision in this case is we're going to fail to reject the null hypothesis. Now let's think about what that means. The null hypothesis says there's no difference between our sample mean and the population mean. That any difference we're seeing is just random error. And if you were to look at the whole full population that our sample comes from, the mean would be equal to the population mean. So the null hypothesis says there is no difference. And we fail to reject that. In other words, we agree with it because our sample mean did not fall in one of the critical areas. So we fail to reject the null hypothesis. We fail to see a difference. There is no difference. That this mean is really the same as this mean if you were to look at everybody in the population that this sample came from. That the difference that we're seeing here is just random error. That's what we're saying. So this is the decision, but it's not the explanation. The explanation says that the number of sodas sold, we can say it a lot of different ways, isn't affected by tax, because we're saying that the number of sodas sold after the tax is essentially the same as the number of sodas that are sold before the tax. You could say it that way too. You could say that the number of sodas sold is the same before or after tax. Lots of different ways to say it, but that is your explanation. The last thing you're asked to do is to figure out Cohen's d. Now, we don't typically figure out Cohen's d when we don't have a significant result. So in this case, on your assignment, you can just say, we don't figure out Cohen's d because the result was not significant. But I'm not going to penalize you if you figure out Cohen's d either, because sometimes it is interesting to look at Cohen's d, even when we have a non-significant answer. So in this case, for Cohen's d, we have a different formula, which looks the same as the z-score a little bit. At the top in the numerator, it's the mean of the sample minus the mean of the population. But this time we just divide it by the standard deviation. So the standard deviation was given to us as 60. So basically what we have then is our mean of 395 minus our population mean of 420 divided by our standard deviation of 60. So we have 25 divided by, or sorry, negative 25 divided by 60. And that actually gives us a Cohen's d of 0.42. Now you might be saying, well, it's a negative 0.42, but Cohen's d we actually just report typically as a absolute value. We don't talk about the negative. If you put a negative there, it's not going to be wrong. So this is an effect size. This is an indication of the real magnitude between these two means. And it's interesting because a Cohen's d of 0.42 is, that's a small to medium effect size. It's almost a full-on medium effect size. So what that tells me as a researcher, and you don't need to know this necessarily unless you're interested, is that there might be something going on here, but maybe my n is too small and I've somehow missed it. I've made a type 2 error perhaps, in that I've failed to detect a difference that's really there. So sometimes a researcher will do Cohen's d after a non-significant result, and if it comes up to be something, medium, then maybe I might want to go back and redo my study with more n. Maybe my n is just too small to statistically detect the difference. Okay, I hope this helps. So for this assignment, you have been given these answers, but I don't want you just to mindlessly plug them in. I want you to really go through and think about this. And as always, contact me if you have questions. I'm here to help.